Okay, so the other method is by elimination. Now, guys, you know how to solve a system by substitution, and we're about to learn how to solve a system by elimination. Be strategic with some of these cases. If it doesn't say how to solve it, what method to use, then you have a choice, either substitution or elimination. In many cases, like number one we did, for many of you, it might be easier to use substitution. So whenever you can easily get a variable by itself, substitution is the easiest to deal with, because you end up with equations which you've dealt with for many years. You dealt with this idea right here for many years. So if you can use substitution, and the easiest way to use substitution, if you can pick an equation, and you can easily get a variable by itself, meaning that the coefficient of x or y is what? 1. If the coefficient of x or y is not 1, then I would do elimination. All right, so let's talk about elimination. All right, so elimination. So let's solve these systems by elimination. Or addition, depends on the textbook. Some textbooks will say elimination, some will say addition. All right, so we're going to start with a simple one, the simplest you can have.
1 plus 1.
Well, pretty much that's what's going to happen. But it's not going to be that simple on your test. So, but you need to understand the idea. So let's look at this system right here, number 1. We have 2x plus 2y equal negative 2, and then 3x minus 2y equal 12. Okay? All right. Now, I could easily have used substitution with this, because I could have picked the first equation, and if I solve for x, I could divide everything by what? 2, and I would not have any fractions. The same thing for y. I could have divided everything by what number? 2. So I could have done substitution with this. But let's talk about elimination. So notice that one of the words in the title is addition. So if I add those two equations, if I add them, what happens if I add these two equations? The y's are eliminated, hence the idea of elimination. So I'm using elimination and addition. So I'm adding, and when I add, the y's are eliminated. I end up with 2x plus 3x is 5x equal what? 10. And then how do you solve for x? Divide by 5. And so what's the x coordinate of my solution? 2. There's your x coordinate. So your solution is going to have x coordinate 2. Now to find the y coordinate, you got to go back to one of these equations. Does not matter which one. And wherever you see the variable x, you're going to substitute what? 2. So you pick an equation. Does not matter. You'll get the same solution for y, the same value for y, regardless of which equation you choose. So for example, if you choose the first one, 2x plus 2y equal negative 2. And wherever you see the variable x, what do you substitute? 2. So you're still going to use the idea of substitution like you did at one point in the substitution method, because at some point, didn't you have to substitute? And when I say substitute, I mean this. Look, once you found one of your values, didn't you have to substitute into one of the equations? Yeah. So you still have to use that idea with elimination. So once you found the value of x in this case, you go back to one of these equations, doesn't matter which one, and wherever you see the variable x, what do you substitute? 2. So I get 2 times 2 plus 2y equals negative 2. What's 2 times 2? So I get 4 plus 2y equals negative 2. What's the next step? How to get y by itself? Subtract 4. So I get 2y equal negative 6. So what's my y coordinate? Not 3, but a negative 3. So there's my solution. So your solution, so if I were to graph those two lines, where would they intersect? At 2, negative 3. That's where they would intersect. Now, if you had used the second equation instead, you should have still, that's a 12 right here, you should have still gotten y equal negative 3. So let's check it. 3 times x, what's x? 2 minus 2y equal 12. 3 times 2 is 6 minus 2y equal 12. Subtract 6. I get negative 2y equals 6. Divide both sides by negative 2. I still get my y coordinate as what? Negative 3. So it does not matter which equation you use.
So the solution that we find is where the two lines intersect.
If you were to graph, right, remember when we first started talking about a system, each of those equations has an infinite number of solutions. When solving a system, you're finding out what point do they have in common. So that's their intersection, if you were to graph them. All right, let's look at number 2. All right, number 2, we have 4x minus 2y equal negative 1, negative 4x plus 4y equal negative 2. Okay, now let's talk about being strategic about this. Notice that at some point you will use addition. And when I use addition at some point, I want one of the variables to be eliminated. And in order for the variables to be eliminated, if you look at this, you see the y's were eliminated, right?
Yeah.
What did you notice about the coefficients of both y's? They were opposites. Good. I want you to use the word opposites. What's the opposite of 6? Negative 6. That means if you add 6 and negative 6, you get what number? 0. So if I look at number 2, can I go directly to adding those two equations? Yes. Because what variable will be eliminated? The x. So the whole idea is to eliminate one of the variables, and in order to eliminate one of the variables, you have to have coefficients that are opposites of each other. And so in this case, the coefficients that are opposites of each other are with the variable x. So if I go directly to adding, 4x and a negative 4x is 0. What's negative 2y and 4y? 2y. So I get 2y equals a negative 3. And so to get y by itself, you're going to divide both sides by 2. Yeah, so I get y equals a negative 3 halves. Okay? So I found the y coordinate of my solution. So far my solution has y coordinate negative 3 halves, or negative 1.5. Now to find the x coordinate, you got to go back to one of those equations. It does not matter which one. And where we see the variable y, what do you substitute? Negative 3 halves. It does not matter which one. So I'll do both for this one. I'm not going to do both for all of them. I'll do both for this one. So let's look at the first one. Let's suppose someone chose the first one. And so, remember, y is this right here. So I'm going to say 4x minus 2 times y. What's y? Negative 3 halves. And that is going to equal a negative 1. All right, so now you got to look at this right here. What's a negative 2? A negative 2 times a negative 3 halves. That would be a positive 6 over what? 2, which is what? 3. So this right here becomes 4x, not minus 3, plus 3. 4x plus 3, because this is a negative 2 times a negative 3 halves is a positive 6. And that's going to equal a negative 1. So what's the next step? Subtract 3 from both sides. So I get 4x equal negative 4. So what's x? Not 1,
-1.
-1. So your solution is -1, comma, -3/2. That's your solution. If you had chosen the other equation, this one here, you would have gotten the same value for x. -4x plus 4y equal -2. So again, where we see the variable y, you're going to substitute -3/2. So -4x plus 4 times -3/2 equals -2. All right, now let's get this right here. What's a +4 times a -3/2? A +4, that's a +4, times a -3/2.
-6.
So it's -12/2, which is -6, right? So it becomes a -4x minus 6 equal -2. What's the next step?
So 6.
Add 6 to both sides. I get a -4x equal a 4. I'm running out of room. So -4x equal +4. But I got to divide both sides by -4, right? So what's 4 divided by -4? -1. And so we had gotten here. So again, it does not matter which equation you choose. But the point with both of those equations is that if I'm going to solve this by elimination / addition, at some point I'm going to add them. And when I add those two equations, I need for one of the variables to be eliminated. And in order for the variables to be eliminated, their coefficients have to be opposites of each other. Okay? All right, so let's look at number 3.
So if we're looking at two equations, and we notice that they are not the opposite.
We're about to do one.
Okay.
Number 3. Okay, number 3, suppose we had this one. Suppose we had -6x plus 5y equal 22, 2x plus 3y equal 2. So -6x plus 5y equal 22, 2x plus 3y equal 2. All right, can I go directly to adding them? No, because adding them, one of the variables won't be eliminated. Because if you notice the coefficients of x, those are not opposites. Here, the coefficients of y, those are not opposites. So what you got to do now is you got to rewrite one of those equations, or both, so that way one of your variables can be eliminated. Now, let's talk about this. Suppose, and it does not matter which one, by the way. Suppose someone wants to eliminate the x's, and you could. Someone else could say, well, I want to eliminate the y's. You could do it as well. But if I want to eliminate the x's, look at the coefficients. You have a -6 and a 2. What you want to look for is the least common multiple of those two. What's the smallest number that -6 and 2 go into? 6.
Yeah.
6. I said least common multiple. So let's remember what multiples are. What are the multiples of 6? Well, there's 6, 12, 18, 24, and so on, right? 6 times 1, 6 times 2, 6 times 3, 6 times 4, and so on. What are the multiples of 2? 2, 4, 6, 8, 12, and so on. So here are the common multiples. These are all common multiples, right? There are an infinite number of them. Which one's the least? 6. 6. Now, you could have used a common multiple. It didn't matter. If someone wanted these coefficients to be 12, go for it. Does not matter. All right. So here's the idea. Suppose I want to eliminate the x's. Suppose I want to eliminate the x's. All right, eliminate the x. I need these two to be opposites of each other. So when I look at common multiples, I also need to make sure that one's positive and the other is what?
Negative.
Negative. All right. Now, so I'm going to use the least. I'm not going to use a common. I'm going to use the least. What's the least of negative 6 and 2? 6. But one's already negative. The other's already positive. So I don't have to worry about a negative. This is already a negative 6. So all I got to do is make this a what? Positive 6. And here's what you do. So I'm going to rewrite this over. And to get this to be a 6, you got to multiply both sides by 6. I'm sorry, by 3. Thank you. By 3. So times 3 times 3. Remember, what you do to one side, you do to the other. So you got to show this step. You got to show this step. So then this becomes, notice, this becomes this system now. Negative 6x plus 5y equal 22. And then what was the next equation? 6x plus 9y equal 6. All right. Now I can do, 2x times what is 6? I need for those to be 6, right? All right. Y'all see where the 3 comes from, right?
Yeah.
Okay, because you need, remember, we want the common multiple to be 6. Well, this is not a 6x, that's a 2x. So in order to make this a 6x, I got to multiply by what number? 3. But remember, this is an equation, so what you do to one side, you do to the other. So you got to multiply both sides by 3. Now can I add these?
Yep.
Yes, now if I add those, the variable x's go away. What's 5y and 9y? 14y equal 22 plus 6? 28. Then divide both sides by 14. And I get y to be what? 2. So I found the y coordinate of my solution. I found the y coordinate of my solution. Okay? Once you find the y coordinate, what's the next step? Substitute 2 into one of the equations of the original problem. So it does not matter which one. Just pick one. Which one do you want to choose? I'm not going to do both. Which one? You tell me which one you want to look at. The first one? All right. So you're going to substitute y equal 2 into the first equation. Substitute y equal 2 into the first equation. So here's my first equation right here. So it's negative 6x plus 5y equal 22. Now someone else could have chosen the other equation. So some of you may be doing the second equation. It does not matter. You'll get the same value for x. So I get negative 6x plus 5 times y. What's y? 2 equal 22. What's 5 times 2?
10.
So negative 6x plus 10 equal 22. Subtract 10 from both sides. I get negative 6x equal 12. So what's x? Negative 2. So my solution is negative 2, comma 2. Negative 2, comma 2. All right? That's your solution. And again, you can check. You can check these. So remember to check, go back to the original, right here. Let's go back to both equations. So you have two equations, 6x plus 5y equal 22, and the other one is 2x plus 3y equal 2. And so wherever you see an x, what are you going to substitute? Negative 2. Wherever you see a y, you're going to substitute 2. So I get negative 6 times a negative 2 plus 5 times 2, and I want to see if that's going to equal 22. What's negative 6 times a negative 2? Positive 12. 5 times 2 is 10. It's 12 plus 10 equal to 22. Yes. Over here, 2 times negative 2 plus 3 times 2. I want to see if that's going to equal 2. Is a negative 4 plus 6 equal to a 2? Yes or no? Yes. So that's my solution. Okay? Now, if someone wanted, I'm going to go back to the same problem and see how I ended up eliminating the x's. So now think about this. When you eliminate the x's, what variable are you going to end up solving for? Y. So if I were to eliminate the y's, what variable would I end up solving for? X. And I would end up with x being what? Negative 2. So let's see this. So let's eliminate the y's this time, just to show you that it did not matter. So let's eliminate the y's. All right, so remember my equation was this, my system was this rather. All right, if I want to eliminate the y's, remember at some point you have to add, right? So if I want to eliminate the y's, these coefficients have to be opposites of each other. Well, what's the least common multiple of 5 and 3? 15. Least common multiple of 5 and 3 is 15. So I need these coefficients to be 15. One negative, the other one what? Positive. In both cases, they're both positive, right? All right. So notice that when I eliminate the x's, I just had to multiply the second equation by 3. Because remember, when I eliminate the x's, I need to have my least common multiple being 6. So this was already a negative 6. I just had to make this a what? Positive 6. That's why I just multiplied this equation by 3. But for this one, do y'all see I'm going to have to multiply both equations by a number? So over here, and remember, they're both the same sign right now, right? In order for them to be opposites, they have to have different signs. So let's suppose you want this first equation to have this coefficient being negative. What do I need to multiply? Let me go ahead and rewrite this over. What do I need to multiply the first equation by to get a negative, what number do I want here? 15. Negative 3. So negative 3, negative 3. What do I need to multiply the second equation by to get a 15? Not negative, 5. Just 5. Times 5 times 5. Now remember, what you do one side, you have to do the other. So some students, a common mistake is to forget to do the other side. And so now this becomes distribute, what's negative 3 times negative 6x? 18x minus 15y equal negative 66. Second equation, what does that become? 10x plus 15y equal 10. And now I add them up. What's 18x and 10x? 28x equal negative 56, right? Divide both sides by 28. What's x? Negative 2. And isn't that what we got for x here when we did that substitution? Okay. So it did not matter which variable you eliminate. Does not matter. Okay, so let's kind of review this little steps right here. So let's think about what we did. So step 1 was we multiplied one or both equations to make one of the coefficients to be opposites. Remember that? Okay. Then step 2, once they became opposites, what did we do to both equations? We added them, and then we solved for the remaining variable. So to find the other variable, I had to do substitution. And then you just write your answer as a point. Okay? All right, let's look at another one. Okay, so let's look at number 4. So number 4, suppose you had negative 5x minus 3y equal negative 3, negative 7x plus 12y equal 12. All right. Now be strategic. Would you use substitution or would you use elimination? I would use elimination because in substitution, in both cases, you would have fractions involved. All right, now, so I know I'm going to use elimination. Which variable would be the easiest to eliminate? The y's, very good. The y's. Because look at negative 3 and 12. What's the least common multiple of negative 3 and 12? 12. And this is already a 12. If you were to eliminate the y's, if you were to eliminate the x's, then you could have, what's the least common multiple of negative 5 and negative 7? 35. But you'd have to multiply both equations by a number. So if I were just to eliminate the y's, eliminate the y, the least common multiple is 12, and so and also notice that one's negative, the other one's positive. So I just need to multiply. I'm going to go ahead and rewrite the equation, the system over. I just need to multiply the first equation by what number? 4. So both sides. So what I do to one side, I do to the other. What's the next step? Distribute first. So this becomes negative 20x minus 12y equal negative 12. And then negative 7x plus 12y equal 12, right? Now what can I do? Add. So when I add them up, the y's are eliminated. So I get negative 27x equal 0. Divide both sides by negative 27. I get my x coordinate to be 0. So far my solution has the x coordinate being 0. To find the y coordinate, that's why I take 0 for x and I substitute into one of the equations. Does not matter which one. Does not matter. So which equation do you want to choose? The second one? All right, so I'm going to substitute that into the second equation. So negative 7 times 0 plus 12y equal 12. Negative 7 times 0 is 0. What's 0 plus 12y? Equal 12. So it's y. 1. So my solution is 0, 1. That's your solution. All right, so notice it was easier to eliminate the y. Now let's talk about eliminating the x. Let's suppose that someone did that. Eliminate the x. So let's see what you would have to do. So suppose you wanted to eliminate the x instead. Notice though, if you're going to eliminate the x, you need to find the least common multiple of negative 5 and negative 7, which is 35. So I'm going to go ahead and eliminate the y. I'm sorry, the x. So I'm going back to my original system, just rewriting it. So if I eliminate the variable x, my least common multiple is 35, right? Mm-hmm. So that means that I got to multiply, and by the way, they're both the same sign, so whatever one of those equations, I have to multiply by a negative number. Okay? Does not matter which one. So I know that though, in both cases, I have to multiply both equations by a number. Which one do you want the coefficient to be positive? First or second? Top or bottom? Which one? The bottom one? Okay. So you want this one to be positive. All right. So what do I need to multiply the first equation by then? No, you told me that you wanted.
Oh, yeah.
Which one do you want to be positive? You said the second one.
7.
So this will be 7. Then the bottom one, I have to multiply by a negative 5. Both sides. That's what you have to do. And in some cases, you will have to do both. So you need to learn how to do that. And then distribute, I end up with an equivalent system that becomes negative 35x. What else? Come on, guys, you need to be able to do this. Minus 21y equal negative 21. And then a second equation becomes positive 35x minus 60, y equal negative 60. Is that right? Okay. Then I add them. The variable x is eliminated. So I get a negative 21y and a negative 60y, which is negative 81y, equal negative 81. Divide both sides by negative 81. I get y to be 1. All right. So it did not matter whether you eliminate the x's first or the y's. It does not matter. But it is easier to use elimination here rather than substitution. Because substitution, you'd have all these fractions. All right, let's look at number 5. So number 5, suppose we had this. All right, you had 3x plus 6y equal negative 9, 2x plus 9y equal negative 26.
Plus 9.
9y equal negative 26. 2x plus 9y equal negative 26. So determine which, so adding those equations right away is not going to help because the coefficients are not opposites of each other. So which variable do you want to eliminate first? Give me one. X? All right. So what's the least common multiple of 3 and 2? All right. Now remember, they're both the same sign. So when I multiply, I'm going to have to multiply both equations, right? And it didn't matter if I did the y. I still have to multiply both equations by a number. All right. All right. So, Okay, when the bottom to be positive, the top one to be negative, okay? So what would I need to multiply the negative 2? Good, both sides. Bottom would be by positive 3, okay. And then we distribute, get rid of the parentheses. So I end up with an equivalent system. So the top equation becomes negative 6x minus 12y equal positive 18. The second equation becomes 6x plus 27y equal, what's that? Negative 72, is that right? 78? Okay. Now can I add those? Yes, so when I add those, a negative 12y and a 27y is 15y. And what's that, 60? Divide both sides by negative 60, thank you. Divide both sides by 15, that's negative 60, by the way. I get y to be negative 4. Right, so there's your y coordinate. So my solution, my y coordinate's negative 4. To find the x coordinate, you just substitute negative 4 back into the other equation. One of the equations. It does not matter which one. I'm going to just go ahead and use the first one. So we're going to take this and substitute into the first equation to find x. So I get 3 times x plus 6 times y. What's y?
Negative 4.
Equal negative 9. So that's 3x minus 24, right? What's the next step?
Absolute being 6.
All right. So I get 3x equal 15. So what's x?
5.
5. So x is 5. And you can check if you need, if you want to. You don't have to, but you can check this. You got to check both equations. 3x plus 6y equal 9. 2x plus 9y equal negative 26. So where we see the variable x, you're going to substitute 5. Where we see the variable y, you can substitute negative 4. So look what we get. We get 3 times 5 plus 6 times a negative 4, and I want to make sure that's equal to 9. 3 times 5 is 15, plus a negative 24. Is 15 plus a negative 24 equal to 9? Did I do so? It's not. Oh, I'm sorry. It's not 9, it's what? Negative 9. So is that equal to negative 9? Yes. All right. Okay, so it's a negative 9, not 9. Over here, 2 times x, x is 5, plus 9 times y, negative 4, and I want to see if that's going to equal negative 26. Is 10 plus a negative 36 equal to negative 26? Yes. So both of them work. All right, now let's do one more. I want to show you something. Notice that those equations, those systems are easy to solve because when I did the substitution here, when I went to this point right here, in all cases, I substituted an integer to make things a lot easier. There might be a situation on one of your worksheets where you may end up something like this. So I'm making this up. Let's suppose we had this system. Let's suppose we had 3x minus 2y equal 5, and then 4x minus 7y equal 1, negative 1. All right, suppose we had this system. Again, I would not do substitution here. I would do elimination. Which variable do you want to eliminate? Does not matter.
X.
The x? All right, so if we eliminate the x, what's the least common multiple of 3 and 4?
12.
12. All right, so we eliminate the x. So I'm going to rewrite this over. All right, so again, you need opposite signs. So let's make the first equation negative, the coefficient negative. So I need to multiply this by a negative 4, both sides, right? And this by 3, both sides. Now distribute. What does that first equation become? Negative 12x plus 8y equal negative 20. Then 12x minus 21y equal a negative 3, right? Now can I add these? So when I add those, I get 8 and a negative 21 is negative 13. Is that right? Is that right? 13? Negative 13?
Negative 13.
Y equal negative 23, right? To get y by itself, I divide both sides by negative 13. And so I get y to be positive 23 over 13. I want you to notice that this time my y value is a fraction. So just like before, you would substitute that value into one of your equations, but you end up dealing with fractions. What I would then do is go back and to get, okay, so remember, trying to solve for x, right? So remember, what we did first was we eliminated the x's, and we found the y value. Someone else could have done what first? Eliminate the y's and found the x value. So here's what I'm trying to say. If when you eliminate the first time, you end up with a fraction, go ahead and do elimination again for the second one. So that way you don't have to deal with fractions. So in other words, now we're going to eliminate what variable? The y. So let's eliminate the y. So I'm going to go ahead and rewrite this over. And so if I'm going to eliminate the y, what's my least common multiple? 14. And let's go ahead and make the first equation the value for y, the coefficient of y being positive. So I'm going to have to multiply the first equation by -7 and the second equation by +2. +2, right?
Divide the 7 into 14. I think that's what you did to get that first number.
Yeah. 7 times what's 14? 2. All right, then you distribute. I get -21x plus 14, right? Equal what, though? -35. Then the second equation becomes 8x minus 14y equal what? -2. Now I add them up. What's -21x and 8x? -13x equal -37. Divide both sides by -13. And I get x to be a positive 37 over 13. So you found your solution. Your solution is 37/13, comma, 23/13. Notice though, if you had gone directly and done substitution, it would have been a little bit more difficult. So I want to show you what's going to happen. Because in all the cases we did do substitution, right? What I'm saying is that when I went back here, I did substitution, correct? And it's easier to do substitution because those are just integers. But if you end up with a fraction, it's easier to do elimination again to get the other value. So let's see what would have happened, though, if you had done substitution. So you see we got this first, right? So that means I go back to one of those equations here, and wherever I see the variable y, rather, what do I plug in? 20/13. So which one do you want to go back to? First or second? Let's do the first. All right, so I'm going to substitute y equal 23/13 into the first equation. And so my first equation was this. So notice what would have happened. You would have said this. You would have said, all right, I'm going to get 3x minus 2 times y. What's y? 23/13, and that's going to equal what number? 5. This right here becomes, now you got to think, what's a -2 times 23/13? That's 3x minus what? 46/13 equal what? 5. Then you would have had to do what to both sides next? Add the fraction to both sides, just like this. Then you say 3x equal. All right, now you may want to use your calculator with that part.
Make it a mixed number?
Make it a mixed, well, your calculator is going to give you a mixed number. You have to convert it back to an improper fraction. So you'd say 5 plus 46 divided by 13, right? Equal, you get this decimal. Remember, to convert that decimal back to a fraction, you got to do second PRV right here. Press equal, and you get this mixed number. You get 8 and 7/13. Then you got to convert this back to an improper fraction. So 13 times 8 plus 7 equals 111.
Yep.
So 111/13. So that's what this is. Then you got to get x by itself. So then you got to divide both sides by what? 3. So let's see if you remember something from a previous course. You're dividing fractions here, right? So you're saying 111/13 divided by 3, right? How do you change what do you do with the division? Change division to multiplication. So this becomes 111/13 times the reciprocal of 3, which is 1/3. And this and you can reduce, by the way. 3 to 3 is 1. 3 into 111 is 37. You remember how to determine if a number is divisible by 3? Divisibility rule for 3? You add up the digits. What's 1 plus 1 plus 1? 3. 3 is divisible by 3.
What?
Yeah. So like if I had 60, 60, well, that would be too easy. Let's do 40, 42. What's 4 plus 2?
6,
Is 6 divisible by 3?
yes.
So 42 is divisible by 3.
That's a good trick. I like it.
14.
Where were you in like 6th grade?
So, but it's just memorization though. You'd have to memorize that.
I'm still working on my multiplication.
Yeah, I know. So don't even worry about this, huh? So 111 divided by 3, I can reduce. That's, what did we say that was? That was 37? And what's 37 times 1?
37,
13 times 1?
13.
Isn't that what we had gotten earlier? But notice, which one's easier to deal with? Now, here's a question. If you end up with a y with one of your coordinates being a fraction, is it easier to go back and use substitution, or just use elimination again? Use elimination again. Okay?
So we can choose to eliminate both one and we come up with a fraction.
Yeah. Yeah. In fact, if you want to, you can do elimination twice. I don't care.
All of them, right?
Yeah.
Because that's what I was thinking. I was like, why can't we do that?
You
with
could do
all-
elimination twice. So what she's saying is this: when we had done
like on number 5.
this one here, like when we got y to be -4, and I used substitution to find x, she's saying, well, could here we had to eliminate the x's, right?
Mhm.
We had to eliminate the x's here. So she's saying, all right, well, instead of doing this, could I just go and eliminate the y's? Yeah, you could do that. It does not matter. I don't care.
Be well-rounded and-
But that's not what the procedure is, but it's okay with me if you do. Because many times I do that. It's easier sometimes. Okay? All right, any questions at this point? All right, so let's go ahead and take a break. And then what's going to happen when we come back is this.
Testing the